In this presentation, we look at binary search trees and in particular the height of a binary search tree. So, given that a binary search tree contains n records stored in the internal nodes, we're going to use that number there, n, the height of a search tree is computed as follows. The log to the base 2 of n plus 1, we compute that number first and then we find the ceiling of that value. Those brackets there at the side, that indicates the ceiling function. We'll show what that is shortly. So what we have to do is compute log to the base 2 of n plus 1 and then find the ceiling function. Before we look at an example, we might also look at a related matter, the maximum number of comparisons to find a record in a binary search tree. The height of a binary search tree is equivalent to the maximum number of records. So that's important. The height is equivalent to the maximum number of comparisons needed to find a record in a database that is structured as a binary search tree. So essentially, if you're asked for the maximum number of comparisons, you are really being asked the height. Okay, so let's look at an example now. Suppose a binary search tree contains 3 million records. What is the height of this binary search tree? Well, we'll start off with calling this h equals the ceiling function of log of 3 million and 1 to the base 2, and we find the ceiling function of that. This here is a bit of calculator work. We use our pocket calculators to compute that. The answer in that case roughly is 21.51, and the ceiling function of that is the next highest integer, that is 22. So the next highest integer for 21.51 is 22. So the answer is height is 22. That is also the maximum number of comparisons that would have to be computed to find a record, and that ends our presentation.